Section 7.2, Part 2, the Standard Normal Distribution. Lesson objectives. In the previous video, we learned how to find the area under the standard normal curve. In this video, we will find the z-scores for a given area and interpret the area under the standard normal curve as a probability. Lesson objective number 2. We'll begin with the problem. Find the z-score such that the area to the left of the z-score is 0.7157. Now in this problem we are given area and we're trying to find the z-score. So our first step is we draw a picture. In this picture we see that the z-score has to be a positive number. The reason why is we're looking at area to the left and this number is larger than 0.5. So if you recall, the area to the left of 0 for a standard normal curve is 0.5. This is larger than 0.5, so it has to be a positive z. So from the picture, we see that the z-score must be positive. So we go to Table 5, and in Table 5 we are looking at these area values to the closest thing to 0.7157. So we look through the body of the table, and here we see 0.7157 exactly. So this gives us 0.5, and in this column 0.07. So our z-score is 0.57. Let's look at another example. Find the z-score such that the area to the right of the z-score is 0.3021. Let's do our picture. Again, we're going to the right this time. Now this again will produce a positive z, because since we're doing the area to the right, we know this has to be a positive value because the area to the right of 0 is 0.5. This is smaller than 0.5, so it has to be a positive z. Now, in order to use Table 5, we must compute what is the area to the left of this z-score. So we simply do 1 minus, because this is the area to the left. That's what the values give us in Table 5. So going to Table 5, we're going to look for the closest thing to 0.6979. So as we scan these values, we see right here between these 0.6979 is between these two values. So our rule of thumb is going to be whatever number is closest to this number, that's what we're going to use. So this one is closer to 0.6979. So again, this is a z-score 0.5, and then in this column 0.02. So our z-score is 0.52, and that agrees with our picture. Here's another example. Find the z-scores that will separate the middle 80% of the area under the standard normal curve from the 20% and the tails. Well, our first step is to draw a picture. Here's our middle 80%, and the remaining 20% are in the tails. So therefore this has to be 20% divided by 2, and this is 20% divided by 2, which is 10%. So in order to find our first z, and clearly this z is going to be negative, we would look to the closest value to 0.1 in our table. This turns out to be a negative 1.28. Now to find our second z-score, again this will be positive because it is above 0. We are going to look for the closest thing to 0.9, because here to the right we have 0.1, so therefore to the left we're going to have 1 minus 0.1, which is 0.9, and we see that this z-score is a positive 1.28. Lesson objective number 3. Okay, this is the notation for probability. So when you see this, this means the probability that the z-score is going to be between the values of A and B. This notation here means the probability of z being greater than A. This notation here, this is the probability that z is less than A. Let's look at these with the picture. Probability z is greater than A, here's A. We would shade in this region. That's greater than A. The probability of z is less than A, here's A. We're looking at the area to the left of A. And the probability of being in between A and B, here's A, there's B. So here's some practice problems. Find the probability that z is less than negative 0.23. The answer is 0.4090. Part B, find the probability that z is greater than 1.93. The answer is 0.0268. C, find the probability that z is in between 0.65 and 2.10. The answer is 0.2399. And D, find the probability that z is between negative 2.33 and 3.99. Now with this one we're going to have to use the default. If you recall, if you have a z-score that is greater than 3.49, you have to use the default of 0.9999. The answer to D is 0.9900. For any continuous random variable, the probability of observing a specific value of the random variable is 0. For example, for a standard normal random variable, the probability of A equals 0 for any value of A. This is because there is no area under the standard normal curve associated with a single value, so the probability must be 0. Therefore, the following probabilities are equivalent. So the probability of A of z being in between A and B is equal to this probability with an equal sign, this one, or this one, because the probability of a single value is 0. Here's the readings and suggested problems. Thanks for watching.